Let's talk about web addresses. So I'm over here on my computer and I want to communicate with, let's say, some server over here, right? Maybe I want to make a request to that server. Maybe I want to browse a website that's hosted there. Point is, I want to communicate with it. Trouble is, the internet is made up of much more than just my computer and the server, right? We have all these other devices that are connected to the internet. We have tons of other servers that are connected to the internet. So, how, right? How can I tell kind of the routing mechanisms of the internet that I want to communicate directly with that server? Well, that's where web addresses come in. And more specifically, what we call IP addresses or Internet Protocol addresses. So, what does an IP address look like? Well, it looks something like this: 8.13.156.7. Okay, there's 4 sections separated by periods, and each section can be between 0 and 255. 4 numbers, each number is 1 byte of information. This 8.13.156.7, this is just an example, right? It is a valid IP address, but I don't know if there's anything connected to this IP address. So just keep that in mind. There's many possible valid IP addresses. The only rule is that each section has a number between 0 and 255. So whenever you order a package online, you have a unique address for your home. And that's how the e-commerce store, say Amazon, knows how to send the package directly to your door and doesn't get mixed up anywhere else, right? IP addresses work the same way. Every device connected to the internet has its own, unique IP address. So in this example from before, where I'm trying to communicate with this server, all I need to know is its unique IP address. And if I know that, I can communicate with it. It is important to understand that this format here, right, these 4 numbers separated by periods, this is just one format of an IP address. And it's actually the more popular format. It's called IPv4. But there is a newer format that's being used called IPv6 or IP version 6. And it looks similar, but there's actually way more possible IPv6 addresses than IPv4 addresses. And in IPv6, each section is separated by a colon rather than a period. So we can tell them apart, right? And there's actually 1, 2, 3, 4, 5, 6, 7, 8 sections in an IPv6 address. And each section actually has more information in it. So the point is, there's way more IPv6 addresses, way more possible IPv6 addresses out there than IPv4 addresses. And that's really important because we're actually running out of IPv4 addresses. There's really not that many combinations of numbers here. And so we're running into a problem where so many people and so many devices are online and we're running short on these IPv4 addresses. So IPv6 is kind of given us more options. The same principle applies, right? The addresses are unique and uniquely identify machines on the internet, but we just have more kind of available to us. So as you're looking at IP addresses, just know that you'll see them in both formats. So it seems like IP addresses are very useful. Right? Just like how if I were to give you my physical address, you could send me a package from anywhere in the world. If I were to give you my IP address, you could contact me over the internet from anywhere in the world. But this is where things start to get problematic, right? If I want to contact Amazon's servers, right? Say I just want to navigate to Amazon.com. I want their server to give me a web page. It's not very helpful if I need to know their IP address. Right? I don't have Amazon.com's server's IP address memorized. No one does, right? So that's where DNS comes into play. DNS stands for Domain Name System. And one of its main purposes is to map human readable, right, easily read names like Amazon.com to IP addresses. Okay, so now when I want to go to Amazon.com, I can type into my computer Amazon.com, and the domain name system is responsible for looking up the IP address that's associated with Amazon.com and giving it back to me so that I can make that request to the server that I'm looking to get to, right? So this whole system of essentially going out using IP addresses to talk to computers, that is used. It's just the second step. The first step that our computers kind of do under the hood automatically for us is to resolve a domain name to an IP address. And this has the side benefit of if Amazon wants to change out their IP address, or maybe their IP address kind of just changes because their internet service provider swaps it out on them, they can update this mapping, right? They can update the IP address under the hood without needing to change their domain name. So all the users, right, can still just navigate to Amazon.com, but now they're actually going to maybe a different server or a different IP address under the hood. So just to recap, there's essentially 2 steps every time we want to send an HTTP request to the server on a given domain name. The first step is to resolve DNS. What that means is we're taking the domain name, right, say google.com, and resolving it into an IP address. So we're obtaining an IP address. Step number 2 is to use the obtained IP address to actually make that request across the internet.